Alright, welcome you guys. Today we will be talking about an AP Calculus. AB is evaluating limits analytically. Now, we talked about last time is looking at it graphically and approaching it from a couple of different angles. But today we will actually be talking about analytically, which is the actual formula. Okay, so right now I'm going to bring up this. This is a great article I found evaluating limits analytically, and it's you know, you always want to try step one, then if that doesn't work, do step two and just work your way. Okay. Alright, so first step is use direct substitution when finding a limit. So in other words, plug in the limit and see if you get an actual answer. Okay. Alright, an actual limit that exists. Now if the problem involves a polynomial divided by a polynomial, and when you use direct substitution you get 0 divided by 0, then factor the two polynomials and cancel out like terms, and then try direct substitution again, because you'll always be surprised. If you remember on the last one we talked about it and we got 1/8, and I showed you how you got 1/8. Right, now if the problem involves a radical expression and a direct substitution gives you 0 divided by 0, then rationalize, in other words multiply by the conjugate in the form of 1. Okay, so in other words multiply top and bottom by a rationalization, and it should work out. It does make sense when you actually do it. Alright, now this one's a little bit more complex, but if it involves a rational expression in the numerator or the denominator in a larger rational expression, so like for example f of x over g of x minus 1/7 over h of x, then simplify by multiplying in the form of 1, so you have a single radical expression. So in other words, since g of x is on the bottom here, we multiply everything by g of x over 7. In other words, multiplying by the common denominator in the form of 1, like this. Okay, and you get f of x times 7 minus g of x over h of x times g of x times 7. Okay, now if it's a trig function and direct substitution gives you 0 divided by 0, then try to get it in the form of one of our two special trig limits. Substitute a trig identity or use one of the above strategies. So in other words, if you get the limit as x approaches 0 of sine of x over x equals 1, or sine of x over x, that's going to be equal to 1. Okay, and the limit as x approaches 0 of 1 minus cosine over x, that's going to be 0. If you want to see why these two are true, either look at the graph of the function or use a table of values. Consider the following trig limits that are a direct result of the above. So in other words, you can also say this, limit as x approaches 0 of x over sine of x is 1, and the limit as x approaches 0 of cosine of x minus 1 over x equals 0. Okay. Alright, if the problem involves delta x and a direct substitution gives you 0 divided by 0, then simplify the expression. In some cases you have to use one of the above cases. If all else fail, try using a table of values or graph. Okay. Alright, so some example problems. Alright, the limit as x approaches negative 2 of x to the third, and we just literally plug in negative 2, so negative 2 to the third is negative 8. So we actually get a number. So this is the limit. So this is what this number is approaching. Okay. The limit as x approaches 2. Now if we try direct substitution, we're going to get 2 minus 2 on top, which is 0. And then on the bottom we get 2 squared, which is 4. And 4 minus 4 is 0. So that's an issue. So since this is an indeterminate form, we must try another method, which is factor and cancel. Okay. So in other words, we factor the top, which is negative 1. We factor out a negative 1 and we get x minus 2. And on the bottom we get x minus 2 times x plus 2. These two cancel out. And I'm left with negative 1 over x plus 2. I plug in 2. Negative 1 over 2 plus 2 becomes negative 1/4. And so the limit as x approaches 2 is going to be negative 1/4 of this function. Okay, radicals. Now if you notice this is pretty funky, and if I plug in 0, I'm going to get 0 over 0. So that's an issue. So now what we're going to do is multiply the top and bottom by the conjugate. So we multiply the top and bottom by the conjugate. Okay, and you are going to have to FOIL this top part. Okay, and you should get 2 plus x minus 2 on top. Okay, and on the bottom you should have x times square root of 2 plus x plus square root of 2. Okay, now if we plug in directly, if you notice I have an x on top and bottom, so those cancel out to 1. So if I plug in 0, now I get 1 over the square root of 2 plus 0 plus square root of 2, which is 1 over the square root of 2 plus the square root of 2, which is 1 over 2 root 2. Alright, notice that we have rationalized our numerator and that we have a radical in the denominator of our answer. A radical in the denominator is okay in this case, okay? Alright, and here's the complex fraction. So if we try to work it out by plugging in 0, because the limit's asking as x approaches 0, we would get 0. So we multiply top and bottom by the common denominator, which is x plus 4 times 4. So we times it, we simplify everything, and we get 4 minus x plus 4 over x times x plus 4 times 4. Okay? Alright, so we plug in 0 into this spot. Well, in actuality, if we simplify this further, this is just going to get us a negative x over x. That simplifies out to a negative 1. Okay, and you never want x's in these cases, because when you plug in 0, guess what? Now we're back to the beginning of which 0 over 0. Okay? Alright, so we plug in 0. 0 plus 4 is 4. 4 times 4 is 16, so this is negative 1/16. Okay, now if I do a trig type of conversion, limit as theta approaches 0 of cosine of theta times tangent of theta over theta, I get cosine of 0 times tangent of 0, which is 1 times 0, which is 0 over 0. So that's an issue. Okay, so what I'm going to do is I'm going to kind of convert stuff. Okay, so what I wanted to do, and this is interesting, is you want to convert to one of these. Okay. Alright, so if you notice, cosine times tangent becomes cosine times sine over cosine, which just becomes sine, so it just simplifies to 1. Now, if there was a number here, I would need the same number down here in order to work it out, and then it would be a different number than 1. Okay. Alright, the limit as x approaches 0 of sine of x over cube root of x, if you notice, it turns to 0, 0. So I'm going to rationalize the top and bottom, okay, and I'm going to actually square it, and you'll see why in a sec, because I have to have the x on the bottom. Okay. All right. So sine of x times cube root of x squared, that stays all up here, and then on the bottom I have cube root of x cubed, which just becomes x, and then I move this over to the constant right here. Okay, well this turns into a 1, and then I plug in 0 right here, and then I'm able to get just plain old 0, which is okay. The limit can be 0 if you do that. Alright, so now if I did sine of 2x over sine of 3x, and I'm finding the limit as x approaches 0 of this one, okay, I plug in 0 and I get 0, 0, so that's not good. Okay, so what I do is I times the top and bottom by 2x. Okay, now what I get, 2x and 3x, which is just going to be, I'm multiplying top and bottom by 6x. Okay, so all of a sudden, this becomes two different types of sine functions. Okay. Alright, so right here, the limit as x approaches 0, and if you remember, there was one that looked just like this one up here. Let's go back to it. Where is it? There it is. So this equals 1, so that's a good thing that we got that. Okay. Alright, so this is, now this one isn't x and x, this is 2x and 2x, but as long as they're the same, this works. So this will turn into 1, this will turn into 1, and then all I have to do is worry about this. Okay? Alright, so as x, and as you notice, if I have this x and x here, I'm going to cancel those out. Those are going to cancel out and just leave me with 2/3. Okay? Alright, so this becomes 1, this becomes 1, and this becomes 2/3 because I'm not plugging in anything for that function. And if you remember your rules for limits, when you plug a limit into a constant, you're going to get that constant. Ta-da, you're good to go. All right, now delta x's, when you're working with this, if you get 0 over 0 for this one, since this is an indeterminate form, we must try to find another method, since we want delta x to simplify the expression and eliminate delta x. So in other words, what we are going to do is we're going to change this up and actually multiply it out and then try to see if we can kind of eliminate. Okay? Alright, so as you can see, we've actually FOILed this out, okay, and then we've actually simplified it, and we factored out the delta x, okay, and if you notice the delta x, we want those canceled out. So as x approaches 0 of 2x plus delta x, okay, delta x approaches 0, this changes to 0, and so therefore 2x plus 0 is just going to be 2x. Now in this case we're going to get a polynomial for our answer rather than a number, and I'll explain that later. But that is analytically how you want to do this, and this is going to cover everything, especially in AP. Okay, alright, so that's it. Basically, for evaluating limits analytically. I will talk to you guys later, and have a great day. Bye.